Hello students, welcome to the next lecture on the PY question series. Today we will discuss about power series. We will cover all those questions from the CSIR NET exam 2011 to 2023 as well as GATE mathematics from the year 1997 to 2023. Myself Dr. Harish. You can simply follow my YouTube channel Dr. Harish, where you can see the playlist of the CSIR NET. Here you can see the topic wise as well as the subject wise. Both PY question series is available from the last 12 years. The GATE as well as the CSIR NET examination both appears in this same playlist. So objective is we will cover all those questions related to the power series as well as the radius of convergence, which consists of the part B and part C from these two examinations years. We will explain 35 plus question with the help of the shortcut tricks. Let's quickly recall first of all what is the concept behind that, how you can think about it, and what are the various shortcut tricks for you. So we will cover all those power series questions which is related to these kinds are there. Then whenever you are talking about the power series, the objective is always to find the interval of convergence, interval of the divergence, and the most important thing is radius of convergence. Once we know the radius of convergence, then we can find the interval of convergence and divergence in very simple manner. The question arises is how we can find the radius of convergence. So that's a very simple. We have the two different methods for finding the radius of convergence of the power series, and that method is called as the Cauchy-Hammett formula. That is based on whether the an is the coefficient. Either you can write as a r is limit of the supremum of an raised to power 1 by n, or this. Based on this you can find the radius of convergence of this series. However, if you have this series like of summation of an x minus c raised to power 3n plus 1, or a simple x minus of 4n, how you can find the radius of convergence of this? You can apply the same rule as of this. The only difference is instead of this beta I can use as a 1 over beta. Based on these two power series we can define the radius of convergence r, and hence the interval of convergence is computed by here, where this c is called as center of the power series. So the interval of convergence is x minus c is less than r, interval of divergence is x minus c greater than r. If you have this power series, then the interval of convergence is x minus c is less than of r 1 by beta, where this is called as, this complete is called as radius of convergence, and so on. Another beautiful remark is when you prove that r is 0, then the series converges only at the center, x is equal to c. So it converges center, that's a uniformly. On the other hand, if you prove that when r is infinity, then the series converges for all x in the domain, and this is a very important concept or the shortcut tricks which you use in many of the examples. Another shortcut trick that's very useful for you, if you prove that the power series is convergent at the point alpha, then it is also convergent absolutely for all x which satisfies this inequality. On the other hand, if you prove that the series is divergent at some point, then the series is also divergent for all the values which is greater than of absolute value. The important thing is here is the absolute value, it's a modulus of here. Now we can start with this PY question. Before that, if you want to join with me through my WhatsApp group, you can simply scan and join my WhatsApp group. Now look at this one, how you can solve this. Again you can see this is a beta, so the radius of convergence will be 1 over this form. Now you can see this is my an is 2 raised to power minus n. So I can find the radius of convergence by using the root test. That is, I can use this as an of 1 by n. So can you find the limit quickly? If it is there, it's my 2. Fine. Now since I need a power of this, so my radius of convergence will be my this one. So therefore radius of convergence is my root of 2. So this value is cancelled out. Now it's a convergence. What is the center is 0. It is less than of root 2. So either this or this. Now check at the equality. Now what will happen at the point z is root 2? If you substitute here, it will be my this into 2 raised to power n. It is my 1, and clearly says this series is my divergent. Why? Because you can see every constant series is divergent except 0. Every constant series is divergent except 0, or I can return this number as n raised to power 0 and it's divergent by using p-test. What is the p-test is? Whenever p is less than equal to 1, it's a divergent, and 0 is less than equal to 1. So but we need a convergent, so equality is not convergent. Right answer is my D is the correct option. Look at this another one. Consider the power series here where an is number of the divisors of n raised to power 50. Then your target is to find the radius of convergence of this. Again, a very simple, what you can do, because it's a divisor, so I can know if I call D is my number of the divisors of this, which is always be less than of here. Then what is that? I can take 1 by n raised to power this of here 1 by n, and this is my n of 50 by n. Now take the limit as n approaches infinity, and we all know limit of this is my 1 as n approaches. So this value is my 1, this value is my 1. So what is the meaning of that? Limit n approaches infinity, divisor of here is my 1. What is the divisor of this? Is my an. This is given to an, so that means an is my 1. Now we can apply the radius of convergence. It is 1 over this limit. So 1 over 1 is my A is my correct option. Now look at this another one which is given to you. D is my open set of this, Fn is there. Okay, that is the sequence of the function. This is the sequence of function, and we already give you the previous lecture on the sequence of the function. You can see about this lecture, sequence of the function. How you can solve that? So firstly, sequence here. So you always apply the Mn test for the sequence. So what is the Fn? Fn is z raised to power over n. So firstly, what is the limit of f as n approaches this? This is my 0. So we can apply the Mn test. It comes to be Zn over n minus 0. Over this domain, it is my less than of 1 by n. It goes to the 0. So therefore, this sequence is my uniform convergent. Now, what is the f dash of n is? N cancel, it will be my here. Then again is a sequence. We can find this limit. It goes to the 0. Why? Because this is my less than 1. Then we can apply the Mn test. It will be my supremum of Zn minus 1, which comes to be 1, because the supremum of this is my 1, which is non-zero. It means this is not uniform convergent. Fine. Now they are talking about the series. What is the series of this? Now whenever you are talking about the series, your target is to prove this must be less than of here. So what is that? This is my divergent series. So once this is divergent, it means it is not uniform convergent. Look about this one. It is z raised to power n minus 1 from here. So what is that? This is my, this is a uniform convergent. Can you tell me why? Yes, it's a GP series. So once is a GP series, what will be the sum of this? It is a 1 over 1 minus that, which is a finite and unique. So this is my uniform convergent. So convergent for each. The sequence, this now is a sequence. Again we are talking about this part. Does not converge, yes, but unless z is 0. That is not true, because it is not uniform convergent for all z. So it means this option is also cancelled. Right option is only C is my correct option. Okay, now again you have to find the radius of convergence, so which is again power of 1 by 2. So what is that? Either you can apply this, or you can apply limit of an plus 1 over an. That's on your choice. That's the same thing. So I can, this is my an, so I can see this value is quite easy. So what is that? It will be my 3 raised to power minus 1. So what is the radius of convergence is root 3. This is cancelled, rest are fine. Center is my 1. Fine. So it means the convergence will be center is less than or equal to. So this option is also cancelled. Now you can check about the point at z is equal to root 3. If I substitute this value here, the series will be 3 raised to power minus n. Center is my 1, so I can substitute z minus 1 is my root 3. So this is my root 3 raised to power 2n. Again you can see this is my 1, which is divergent by using the p test or the nth term test. So this is not equality. Equality is not there. So the right answer is my D is the correct option. Okay, consider this one. Then the radius of convergence of this. So if you compare this series by here, clearly say this is the n factorial. N factorial is a real number, because you can see if I open this from 1 to infinity, what will happen? It's a z1, it's a 2, 3 will be 6, and so on. So what is the meaning of that? Whenever it is even, the coefficient of an is my 1, and whenever it's my odd, it is my 0. Fine. Apart from, and when n is 1 odd but not equal to 1, it is my 1. So what is the limit of supremum of an? Fine. So since this is only a 1, so I can't take that, so I will use the another way, an plus 1 over an, which is a 1. Fine. So it means the limit of radius of convergence will be 1 over this is nothing but 1 is the right answer. So C is my correct option. Otherwise there is no need to do like this way. What you can do is you can simply say, if I look at this one, if I compare this series, an is my 1. Fine. Then an plus 1 over an is also 1. So what is the radius of convergence? 1 over limit of an plus 1 over an, which is again a 1 is the right answer. Let px is a polynomial of the real variable x with the degree k. K is my greater than equal to 1. So I can choose the value of k by on. If I choose k is equal to 1, but look at the option, this value is also 1, then you are unable to distinguish between them. So I can choose k is my 2, then this value will be 2, then you can distinguish them. Consider the power series p of n. I consider as k is my 2, so it means p of n is a polynomial of degree 2. So what is that? I can simply take as degree 2. Fine. Then the radius of convergence, what is that? So an will be my n square. Then what will be my radius of convergence? Limit supremum of an raised to power 1 by n. So what is that? And we all know this value goes to the 1 as n approaches infinity. So what is that? This is 1 over 1. It is my 1 is the radius of 1 is my here. You can also apply this another way. You can use this limit of an plus 1 over an. So what is the an plus 1 over an? It is nothing but n plus 1 over n. So what is that? As n approaches infinity, this value goes to the 1. So if I substitute here, it is again my 1. So it is independent of the k. So B is my right answer. Let this is a power series which is a convergent such that this is given to you. An plus 1 over an is my r. This is given to you. P is my polynomial of degree d. So I can choose any degree. If I choose d is 1, then this is my 1. This is my r, but these are the same option. So I can't take as 1. I can simply take d is 2. Then the options are this 2, 2r and r plus 2. Now you can see they are the different option. So I can choose d is equal to 2. P is a polynomial of this. Then the radius of convergence of this one. So what is the a of an is already there. I can choose capital An is p of n an. Now Pn is of degree 2. So I can simply choose is my n square. You may choose as a n square plus n plus 1. You may choose as a n square plus b n plus c. But the best way is the simple as such. Fine. Then I can find the radius of convergence by using this rule. So what is that? This is n plus 1 over n, and this is an plus 1 over an. So take limit n approaches infinity. So this is my 1, this value is my r. So therefore radius of convergence will be my 1 over this. So 1 over r is my right answer, but none of this option is there. So these options are my wrong options. So the right answer is 1 over r. Okay, consider the following series. If f and g are there, which of the following is true? Fine. So look at that. Firstly, we will talk about f of z. What is your an is? N log of n. So I can find the an plus 1 over an. So it will be n plus 1 log of n plus 1 divided by n log of n. So can you take the limit as n approaches infinity? This value will be 1. Fine. This value will be infinity by infinity rule. So I can apply the L'Hopital rule here. Fine. Now this value goes to the 1. So therefore radius of, and small r is the radius of this f. So small r will be my 1 over limit an plus 1 over an. It comes to be 1. Small r is my 1. So a, d option cancel out. Now we will look about g. So for g is my an is e raised to power n square over n. Since it is a n square, so I can choose this value. It is my n over n raised to power n. Now what is that limit n approaches infinity? Denominator value will be 1. E raised to power infinity is infinity. Fine. So therefore radius of convergence will be 1 over an raised to power of this. So r will be my 0. So r is my 0, b is my correct option, c is my wrong answer. P of x is a polynomial of degree d. So I can choose the minimum polynomial as a 2. So an is my polynomial of degree 2. So an is n square. Radius of convergence. So I can choose either of the method. If I choose this method, then it will be limit of n raised to power 2 by n. So we all know n raised to power 1 by n goes to the 1. So it is a 1 of square is 1. So r is 1 is the right answer. On the other hand, if you want to apply this rule, limit of an plus 1 over an. So this is my radius of convergence. So it is my limit n plus 1 over, again the limit will be my 1 over 1 is the right answer. So the right answer is my B is the correct option. The radius of convergence of this series. So if you compare, what is the an? An is my 1. Okay, whatever is there, if you open them, n is 1, it is 1, then it is a 4, then 3 will be 9, and then so on. So each coefficient will be my 1. Or so if an is 1, so an plus 1 over an is also 1. So the radius of convergence will be 1 over limit an plus 1 is 1 over 1 is the right answer. Otherwise, you can write this series as here, when z is even, fine, 4, 6 and here, then the value is 1 apart from z2. So no, you can't say it's a even. So whenever z is n square and n is even, then it's a 1. If it is odd, then 1, otherwise 0. And if you apply this definition, then you have to take the limit sup. So limit supremum is my again 1. It's not, it's an infimum. So the answer is C is my right answer. Consider the power series of this. So an is my log of n. Then the radius of convergence. So I can start with the an plus 1 over an plus 1. So this is a an plus 1 of this. Now what is the limit as n approaches infinity of this quantity? It's a infinity by infinity form. So I can apply the L'Hopital rule. It is my here. So what is the limit of this? It goes to the 1. So therefore radius of convergence will be 1 over limit of this value. It is 1 over 1. So 1 is the right answer of the problem. Fine. Okay, look at this another one. Let R is the radius of convergence of this power series. So this is the A, K is my K, because these are the series K, or you can write as a An is my N. Fine. What is the radius of convergence? So I can simply apply the limit supremum of An of 1 by N, which comes to be 1. Why? Because of this value is, so radius of convergence is my 1. So R is greater than 0, R greater than 0, greater than 0, all are satisfied. R is 0, cancel out, because R is my 1. The series is convergent on this. So what is the meaning of that? Series is convergent on here. So I will check on the boundary points. So at x is equal to plus R means plus 1. So what is your series? Series will be k 1 raised to power k. That is my k. So what is that? This is a constant series. Every constant series is my divergent except 0. Fine. But you can see k start from the 1. It is not a 0. So this means at x is equal to 1, the series is divergent. So this is my closed interval is a convergent option, cancel. Now it does not converge, this fine. Now we will check about x is equal to minus 1. If x is equal to minus 1, your series will be minus 1 raised to power k into k. You can also written this as minus 1 raised to power n into n. Can you say this is the convergent? This is the divergent. Why? By using the Leibniz test. So what is that? This is my an, which is not goes to the 0. Moreover, it is not a decreasing. So it means by the divergent test, by the Leibniz test, this is my divergent. So at x is equal to minus 1, that means the minus of r, the series is divergent. So the series is convergent at here. So what is the meaning of that? This series is convergent at center is 0 on the open interval of r, and whenever it's a greater than or equal to r, it's a divergent. So this is my convergent series, this is my divergent. The series does not converge outside of open interval is my correct option. Fine. It's a very simple. Okay, look at this one. F is a mapping from, F is an analytic function. Fine. F is analytic means that is, you can say it is also the entire function. Okay, this is the power series. That's why I consider this question here. Okay, F is a polynomial if, okay, firstly I will tell you the rule when the complex series is a polynomial. Fine. If you prove that f and f dash is my entire function, fine, that means f is my constant, and every constant function we know that is a polynomial. Now one way is there. Second way is, if you prove that f is your entire function and their singularity is my pole, then it is my polynomial. Fine. These are two ways you can prove any of the function to be polynomial. Look at that. For any a belongs to the C, this is a power series. Fine. Expansion, then an is 0 for at least one n. For at least one n. Fine. It's a very simple. If you simply, okay, what is the relation between an and the function? We all know this is my here. This is nth derivative at the center divided by n factorial. Now, if I simply take my function is sine of z. What is my first derivative? Cos z. Second derivative minus sine z. Now you can clearly say for each a in the C, if I consider a is my 0, fine, clearly says this value f double dash of 0 is my 0. So what is that? If f double dash is 0, it means a2 is my 0. So at least one n. So we can get a 1 n. So that is here. Fine. So if this condition satisfied, no sorry, our target is f is a polynomial if this condition satisfied. Okay, fine. So what is the meaning of that? Now this is my entire, f is my entire function, at f is a polynomial if this is my satisfied. So is this satisfied? How you can say about that? F is a power series, f is a polynomial if this, then okay, that's satisfied. A is 0, a2 is 0, sorry, a2 is 0 for this. What is the meaning of that? Okay, what is the meaning of that? This means z infinity is a infinity. It means this has a pole. So that's a singularity. Because of this infinity, we can say it's a singularity. So singularity at the point infinity is called as the pole. F is the entire function. F has a singularity at the pole. This implies it is a polynomial. So this is my correct option. Now look at the third one. What is the meaning of that? What is the meaning of, okay, what is that? F is bounded. Fine. If f is bounded plus f is my entire function, what is the meaning of that? F is my constant by Leibniz theorem. Fine. So if this is a constant, every constant function is called as the also a polynomial. So this is also the correct option. What is that? Again, this is the generalized. This is the generalized Leibniz theorem. Also, this is nothing but the bounded. Fine. Every is a bounded plus entire, because entire is already given. So it's a constant. Constant means it's a polynomial. So all the A, B, C, D are my right answer of this problem. So this is the way. You can also think about the first, because I consider the simple example as a sine z. Okay. So sine z is also, you can write as exponential, as a power series of this. It's a infinite power series. It's a polynomial also. Okay, look at this another one. Which of the following statements are true? It's a part C question of the June 2018. AK is bounded. Sequence is bounded. What is the meaning of that? If sequence is bounded, it means it is must be less than of something. Fine. What is the meaning of that? Now I can define this sequence. AK z raised to power k. It is less than of m of this. What is that? It is from k is equal to 0 to infinity, and it is an open unit disk, that is here. So what is the meaning of that? This is the infinite series. This is convergent. Why? Because this is my GP series and common ratio is my mod of z, and which is less than 1. So if this is convergent, it means this is also convergent. So that means it is a power series. You can expand it as a power series. Is a fine. If this is an analytic function, so it is given you in analytic function, then AK is convergent to the 0. Okay, how you can prove for the must be 0. Okay, if I simply AK is my 1, that's a constant sequence. Fine. Then your power series of this, it becomes my z raised to power k. And you can say this is my analytic function. Fine. It satisfied this condition, but this value is not goes to the 0. So this option is cancelled. Look at this another one. If f and g are the two power series with a radius of convergence 1, then the product is also power series. Yes, that's true. And this is also obvious too, because if this is the power series, then you will get this. If this is the power series, radius of convergence 1, then the product of the power series is also the power series with the radius of convergence as product of them. So if R1 is the and R2 both is 1, then the radius of convergence of this is my R1 into R2, which is 1. If Fz is the radius of convergence 1, then F is a continuous. Okay, I can simply take same example. If I simply take k is 1, then this series is my here. I can written this as 1 minus z, and you can see this is my, okay, this is my closed interval, open interval. So this is fine. If once is open interval, then this function is my continuous. Fine, because this is a well defined. This is well defined whenever mod of z is less than 1, so it means this function is continuous. So this is also the right answer. If remember, if this condition is given to be like of this, such that less than or equal to 1, then clearly says at this function this is my not continuous. Why? Because at z is equal to plus 1, because the equality appear, this function is not defined, so that why it is not a continuous. But in this case it is an open interval, so once is open interval, it means this is my continuous here. So the right answers are A, C and D are my right answer. Okay, look at this one. Capital D is the open disk, center at 0, open unit disk. Fine. F is the mapping from the capital D to C is an analytic function. So F is given to my entire function. Fine. F is my here, down it's a power series. Okay, that's why again I consider this example in this lecture, because it's given as a power series. F is a constant. F is a constant if F there, okay, I can use the same remark. See, if F and F complement is my entire function, then F is my constant. You can see F is already given to be the entire. Fine. If I assume F bar is my entire also, so what does it means? F is constant. So that's the same statement, F is constant if F is already given to be entire. If this property hold, then it means F is entire is the right answer. Okay, look at this one. What is given to you? U half is greater than. That is because it's a greater than sign. So we will think about the maximum modulo principle. I quickly recall that. What is a maximum modulo principle is? If you prove that a function of the u at the point A is greater than or equal to function at the point of this, where A is in the D and D is the domain, fine, and for all those Z in the domain, then you can say A is my maximum point, and then in this case this U is, or in this case the function U corresponding to the F is my constant. That is the maximum modulo principle. So you can see I only need to prove A must belong to the D. What is the A? A in this case is half. So what is the capital D? Capital D is my, this case, collection of all those points. Now clearly says half is less than 1. So therefore this is belongs to the D. This property is satisfied. So what is the meaning of that? This is my constant is the right answer. Similarly, you can see about that. What is that? If you look about the last option, what is given to you? Z minus A whole square. What is that? This is nothing but the first derivative of this one. Fine. Now it is given to you 0. First derivative, I can divide by 1 by 2 pi iota. That's not a big problem. First derivative is a 0. What is that? It means F is my constant. So this is also my right answer. Now look at this one, the set AN. So we can see the last part, the set is my infinitely. Okay, that's again a very simple. You can think about any of the entire function. Firstly, I can simply whose nth. Okay, firstly, how you can relate them? This is AN, center is my 0 divided by n factorial. I can again consider same example. This is my sin z. Fine, this is the entire function. Fine. What is the first derivative is? Cos z. Fine. Second derivative is my minus sin z. So now at the point z is equal to 0, that is at the point center, f is my 0, f double dash is my 0, f fourth derivative will be 0. So what is that? The set n will be my second, a2 is my 0, a4 is my 0, and so on. So it is an infinite. Fine. So it satisfied this one. But is this a constant function? This is my not constant. So what is the meaning of that? This option is cancelled. So the right answers are my A, B and D are my correct options. Okay, look at this another one. Consider the power series, find the radius of convergence, bounded infinity. Okay, so if you compare this an is my minus 1 raised to power n, 2n factorial. So what is, how you can find the radius of convergence? Because it is z raised to power 2n, so I can written as a 1 by 2. Because it's a factorial, so I can use as a an plus 1 over an. Fine. So what is that? An plus 1 over an. So minus 1 raised to power is a modular sign, is a cancel out. So it's my 2n plus 2 factorial into 1 over 2n. So it's my 2n factorial as limit n approaches infinity of half. So I can return 2n plus 1 in the upside. So 2n plus 2, 2n plus 1 and 2n factorial cancel out. So what is the limit of this? As n approaches infinity, it is infinite. So radius of convergence is my infinite. The first is my correct option. Second one is check whether the set f of z such that this is my bounded. Okay, so what is that? I can return this, I can simply write it as 2n factorial of this part. Fine. Start from the 0 to infinity. I can open this bracket. What is the n0 is 1 factorial, it's my z, plus when n is equal to 1, it is my minus negative 1 over 2 factorial z raised to power cube, plus n is equal to 2, it's a plus, it's a 4 factorial z raised to power 5. So minus, next one is 3, 5, 7, 2, 4, 6 plus and so on. So is there any series? No, because it's a cube, then 3 factorial I can take as a z common. It is my 1 z square over 2 factorial z raised to power 4 over 4 factorial and so on. Is there any series? Yes, this is my cos of z. So basically this is your fz. Now z is my real number. Z is my real number. Fine. So if z is my real number, you know this is my bounded. Fine. But on the real number, z, basically z is nothing but my x on the real number. So this is my unbounded. Fine. So that means the product is my unbounded. So this is my unbounded. So this option is cancelled. The set f of z where x is my 0 to minus 1 to plus 1 is a bounded. That means if now this z is nothing but my x, if this is my minus 1 to plus 1, it means now this case it is my bounded, or we all know this number, if I start with this is less than of the z, and what is the z is, it is my 1, so it is my bounded. So this is my correct option. Last one is f of z has infinitely many zeros. Okay, so you are talking about the zeros. So since we already derived that this is my f of z, so what is the meaning of the zeros? I can take this. Fine. So it means z cos z is my 0. So that means cos z will be my 0 is 2n plus 1 pi by 2. So where n is my, so how many numbers are there? It has infinitely many numbers. You can take as a z is 0, but once z is 0, this complete series is my 0. So that is not a power series. Fine, because it's a 0, 0, 0. So that's why z is non-zero. So therefore cos z is my 0. So it has infinitely many numbers. So it has infinitely many zeros. So A, C and D are my correct options of this example. Okay, let rational number of the complex is here. Then your target is to find the radius of convergence. Now clearly see, can you write this function in terms of an z raised to power n? What is the an? An is nth derivative at the center. Center is given to you, no. So a over n factorial. So you need to firstly find the, when you take n is 1, then you can get a1, then n is 2, then and so on. Then you can create a series. But that's a very lengthy procedure. I will tell you the simple shortcut trick. The radius of convergence is the center minus pole. Fine. So what is the value of the center? Center is given to you, Taylor series at the 1. Can you find the pole? What is the pole of this? So you can see Z is 0 is my pole. So what is the right answer of this? Is simply 1 is my right answer. You can see within a 15 seconds you can get your right answers. Kindly like my video if you really feel it's a very good video for you. F is a holomorphic function that is called as the entire function in the open unit disk. This is given to you such that limit of Z approaches 1 does not exist. That means infinite. What is the meaning of that? Z is equal to 1 is my pole. That is a singularity. Fine. If it is a infinite, you can see it's a infinite, it means singularity. It's a Z is equal to 1 is a pole. Consider the series, it's a power series about the Z is equal to 0, an Z raised to power 1. It's about R is the radius of convergence. Same shortcut tricks you can apply. We got as a pole. What is the center? Center is given you as Z is equal to 0. So what is the radius of convergence? Center is my 0, pole is my 1. So it's absolute value. R is my 1 is the right answer. So you can see within a fraction of second you can solve this without solving any calculation. Consider the polynomial P of Z is my here, where D is my unit open disk, then P of this. Okay, fine, that's very simple. What is the P? P is a mapping. An is my capital N is greater than equal to 1 of this. Very simple. Okay, is a subset of this. Okay, firstly we check about the subset of the real number. Okay, N is my greater than equal to 1. I can simply choose N is my 1. So what is my P of Z? P of Z is my A1 Z raised to power 1. That is a simply A1 of Z. What is that? A1 is non-zero. So I can simply choose A1 is my 1. Z is my complex number. I can simply say iota. So what is my polynomial? P of Z is iota. Is it the subset of R? No. It's a complex number. It is not the subset of the R. So it means the first option is cancelled. Fine. Okay. Look at the open and closed. So whenever you are thinking about the open or the closed, which things come in your mind? That is called as the open mapping theorem. Fine. What is the open mapping theorem is? If you have the mapping from capital F D to C, any of the complex number, and if you prove D is my open, this domain is open, then F of D is also my open. Fine. Now look at what is a capital D. You can see that it's a strictly less than. So this is my open. So if P is my polynomial mapping, so I call F is my P. P is my mapping from D to C. So what is that? It means F of D is my open by using open mapping theorem. So it means this is my correct, close is cancelled. How you prove that it's a bounded? Again, we all know if F is the mapping from this, if I prove that this X is my bounded, then this is my bounded. So again, because it's a mode of this is a bounded, it is open plus bounded as well. So F of D is also bounded. Right options are B and D are my right answer. Okay, look at this another one. F is my entire function. Suppose for each A in the real number there exists at least one coefficient Cn which is 0. For each A, I can simply choose A is my 0. Then at least one Cn which is my 0. Then what you can say about of this? Look at that. If I choose sine of Z, fine, and again An is nothing but nth derivative at the point 0 over n factorial. So this is my here, this is my minus sine Z, and so on. So if I take F is my sine Z, so we will get A2 is my 0, A4 is my 0, and so on. What does it mean? F of even at the point 0, but he said or 0. This is cancel out. Fine. If I take the example as f is my cos z, fine, then what we will get? We will get as a1 is 0, a3 is 0, and so on. That means 2n plus 1 of center is my 0, but now it's a even, so both are cancelled out. Now f of n is my 0 for infinitely many n, for infinitely many n. And the last is there exists some k such that this is 0 for all n greater than equal to k. Okay, so there exists some k, after that it will be 0. How you can say? Okay, if I simply take sine and cosine there, if I simply take a polynomial like z plus 1, fine. So can this condition satisfy? Center is 0, an, cn I can define like here, because you can see a2 is my second derivative over, so what is the second derivative is 0, so there exists at least one coefficient which is 0, that's satisfied. So does it get infinitely many n? Yes, because you can get a third derivative 0, you can get as a fourth derivative 0, so it has infinitely many n. Can you get here? Yes, also, because this is my even, so it has, the set consists of 2, 4, 6, it has infinitely many, so this option is satisfied. Does it satisfy? Yes, there exists k, it is not for all k, there exists k. If I take this example, then I can take k is my 2, so for whenever n is greater than equal to 2, this value will be satisfied. So this is also the right answers. A and D are my correct options. Okay, look at this another one. F is a holomorphic function, again we call as the entire function. Lorentz series is given to you such that this is my 0. Its infinity means is a singularity, fine, that's my pole at the point z is 0. So z is equal to 0 is my pole. Then which of the following is conclude? Okay, so it means this series, fine, it must contain somewhere as 1 over z, fine, then only it will goes to the infinity. So very simple, if I simply take an is my 1 over z, fine, then 1 over z is my entire function, fine, this is my, and this satisfied this property also. Then we can conclude a of minus 1. What is my an? I can written this as nth derivative over n factorial. So what is that? First derivative is minus z square, second derivative is 2 by z cube, and so on. So can you say what is the, how you can say that a of minus 1, a of minus n? How you can compute a of minus n? Okay, so but here is an and we need a minus 1. Okay, there is no need of this because we need all as a negative, so there is no need of this. We can start from here, we can write this series because we need a 1 by z must be there so that it goes to the infinity, or 1 by z square must be there. Okay, this is a negative power, so I can take this as a a1 z, a2 z square, and so on, any of this. Now a of minus 1, this is a of minus 1, the coefficient of this is a non-zero, fine, but a of minus n is always 0, it is not always 0. I can take any of the number, say 3 over z square, plus I can define another number also as say 7 over z cube, and so on. Now clearly says whenever n is greater than equal to 2, I can say a2, n is 2, so a is my, what is the a of minus 2? This is 3, which is non-zero. A of minus 3, 7, non-zero, so this option is cancelled out. Okay, again you can see whenever n is greater than 1, if I take n is my 2, then a of minus 2 is a 0, a of minus 2 is my 3, which is a non-zero again. Whenever n is greater than 1, this is not always 0. Fine. But if I simply consider this series, what is my a of minus 4? There is no coefficient of the z raised to power 4. So a of minus 4 is my 0. But he said for all n is a non-zero. This option is cancelled. Only remaining option is my B is the right answer. What he said, a of minus 1 for some n. That's true because 4 is my sum n. And a of minus n is 0 for all n is my greater. That's the correct statement. So the right answer is my B is the correct option. Okay, now it's a gate 2006 here. So how you can find the radius of convergence? So it's a z of n. So I can take simply limit supremum because there is a single term of 1 by n. So what is that? If I take the limit of this, what is that 1 by n is? The denominator is 3 by this, and this is my n square by n is simple n. So what is the limit of this? And denominator is my 1 because n raised to power n is my 1, and sorry, denominator is my 1. This value will be my e. Fine. So the answer is 1 over e is my radius of convergence. So that is a B is my correct option. Okay. If the given series is convergent at this point, then the radius of convergence of this. Very simple. What is given to you? This is convergent. Fine. This is convergent at equality here. So what is that? Center is 0. Point is given to be here. So I can substitute this value minus center is 0 less than of r. Fine. Then the radius of convergence of this. What is that? 5 is greater than r. Fine. That means r is greater than 5. Now how you can check about the equality? Now since it is existence at the point equality, so that's why you can say this is my equality. So this is the right option. This is wrong because center is 0. Look at the next question. The radius of convergence of the power series here. Now you can see it's my 2 of this. So the radius of convergence will be my of this. Fine. So I can written as limit because it's the power. So I can taken as a limit supremum of an raised to power 1 by n. So what is that? If I simply found an of firstly, it is my 4 of this. Fine. Now since it is depend upon the even and odd, if n is even, this number is my positive. If n is my odd, this number will be my 1 over 4. Fine. Now if you take limit n approaches infinity, the answers are either 4 or 1 by 4, but we need a supremum. Fine. So what is the supremum is 4. So the right answer of this is my radius of convergence. So r will be my 1 over 4 because this is the value of this raised to power 1 over 2. So that is 1 over 2 is my radius of convergence here. So remember, this is the even and odd case, and that's why the supremum concept is applicable. And moreover, this is the absolute value. If somewhere is negative appear, then it's an absolute value. Okay, if the power series is convergent at C, at the 5C, remember this is my convergent and this is my divergent. What is given to you? This is convergent at 5C. So it means 5 iota minus center. What is the center? You can write this in form of here. So C will be my, I can written this number as iota minus 3. So C will be my iota minus 3. This is less than of R. Fine. And divergent. So divergent means 5 iota minus of this is my greater than R. Then the power series also convergent at this. As I told you earlier, if the power series convergent at x is equal to alpha, then it is also convergent at of this. Also convergent. And if it is a divergent at x is equal to beta, this means this series is also divergent at x is greater than. So this is my here, and divergent at minus 3 alpha, minus 3 iota. Then okay, so what is the meaning of that? It means, can you find its r should be greater than of, it's a 3 plus 4 iota, that is the absolute value is 5, and from here it is less than of, it is 3 minus 4 iota, that is again a 5. Fine. Now look at that. If it is convergent at this, so firstly we will check about it. This is my z minus center is my iota plus 3. So what is the value of this? It is my 1 plus 4 iota. It will be my 1 plus 16. So root 17. Root 17 is my near about 4 point something, which is less than of r, which is less than of, sorry, what can you say about that? It's a 4 point. This is r, which is, no, can you say, yes, this is my radius of convergent. Fine, this is the condition, and this value is my 4, which is, no, I can say, how you can say it is less than r? No, oh, that's a mistake. It's a 3 minus 4, it's a 9. Okay, fine, I can use this concept easily. There is no need of doing this. What is that? If x is alpha convergent at this point, then now this a center is 0, but here the center is this. So it means I can prove this for the convergent, it must be less than of convergent at this, and for the divergent I have to prove this is greater than of divergent at this point. Fine. Now we can check about the option 1. If the center is my, z is my here, minus 2 plus 5 iota minus c is my here, so minus iota plus 3, it is, this is the same thing, that's a 4 plus 3. So what is that? It is my 1, I can find this 1 plus 4 is 16. Is it less than of 9 plus 16? Yes, 17 is less than 25, satisfied. Fine. So this is the convergent, correct. Now we can check for the divergent. 2 minus 3 iota minus iota plus 3, and it is greater than of, this is my here 3 minus 4 iota. So it is my 5, 25 plus 16. Is it greater than of the 9 plus 16? Yes, it's a 25, and it is satisfied. So it means the option is correct option. Now look at the second option. We can check about the second also here. What is that? Convergent at this 2 minus 3 iota minus iota plus 3, it must be less than of this number, that is my root 25, sorry. So it is my 5, 25 plus 16. Is it less than of this? No. So this is not convergent, cancel out. Again convergent at this, cancel out. Divergent, that's 2, and we will check about here. What is that? It's a divergent at this, so I can use this concept, minus 2 plus 3 iota minus 5 plus 3. So it will be, it's a 1, it's a 4, it's a 16. Is it greater than of minus 3 plus 3, that is a greater than of 25? No. So it means this is not divergent at this point. So but he said divergent, so this option cancel, only option A is my correct answer. Okay, consider the power series here, which is the following is in the radius of convergent. So again I will apply this definition, limit supremum of an of this. So I can find this value. What is that? If n is my even, the of this is my 1 by 3. If n is my odd, this is my 1 by 5. So what is my supremum of this? So it's a 0.2, it's a 0.33, so it is my 1 by 3. I can substitute this, it is my 1 over 3. So the right answer is my radius of convergence is 3. If somebody asks you the center interval of convergence, center is my 0, so this is my here, and at the point 3 you may check, if you substitute here, check whether it's a convergent or divergent by using the ratio test or the root test. Okay, the radius of convergence of this Now you can see it's a 2 raised to power n. So my radius of convergence will be 1 over 2. Fine. And here is a rule of this. Now since it is 3 raised to power n plus 1, so I can found this as of this manner. So it is 1 plus, so what is the limit as n approaches infinity of this term? So it's a 0, it is my 3. So therefore it is my limit supremum an of 1 by n. It is 1 over 3 of this. So 1 over 3 means root 3 over 3. 1.73 divided by 3 is the right answer. You can write up to the 2 decimal places. Moreover, if you want to apply this rule for finding the radius of convergence, then again the answer will always be the same. This is my here. What will happen? It is my 3 of 1. Fine. So the radius of convergence will be again of this 1 over limit an plus 1 over an. So this is my 1 over 3. Again you can see the same answer you have obtained. The largest interval in which it convergent. So there are the 2 methods. Fine. Firstly I will tell you the simple shortcut trick. Look at the option. So firstly look at the closed interval. So at x is equal to minus 1. What is the series? This is my minus 1 raised to power n. This is my minus 1 raised to power n. So it becomes 1 by n. Is it a convergent? So it is divergent. So it means at x equal to 1 the series is my divergent. But he said convergent and equality appears. So it means this is cancelled out. This is cancelled out. Fine. Now these two options are same. I think one may be the closed interval of this. Fine. Now you can check about at x is equal to plus 1. This series is my minus 1 raised to power 1 over n. Is this series is convergent? Yes, by using Leibniz test. So it means this at x equal to 1 is my convergent. So therefore the series is divergent at minus 1 but convergent at plus 1. So it means this is the right answer, because this is open interval but closed interval is also convergent. So the right answer of this problem is here. This is the first method. Second method is you can find the radius of convergent. So what is the an? An is minus 1 raised to power n over n. So I can find this an of this. So this is a 1 over limit supremum of an of this. So what is the an? The absolute value, this value will comes to be the 1 and this will be my n over this and it is my 1. So the center is my 0, it is my less than 1. Now you have to check at the boundary point what is the value of the x is equal to 1. At x is equal to 1, again this is convergent, and since and x is equal to minus 1, it is a divergent. So the open interval of minus 1, closed interval of 0 plus 1 is the right answer. Okay, the radius of convergence of the power series here, again the same rule, the simple shortcut trick of this one. This is my why, because we are unable to write this function in terms of this. So that's why. What is the center is? Center is my 1 by 4. Can you find the pole of this series? Is a 1. So the right answer is minus, so but the absolute value is my plus 3 by 4. C is my right answer. Okay, if an is a sequence of the real numbers such that this is my convergent but this is my divergent, what is the meaning of that? That's a conditional convergent. Fine. R is the radius of convergent of this, then you have to find it. Very simple. You have to think about this series. If I take this as an, we all know this is my convergent by using Leibniz test. Fine. But if I take the absolute value, if I take an is my minus 1 raised to power n over n, what is the absolute value of this? Is 1 by n, which is divergent by the p test. Fine. Both conditions satisfied. Now can you find the radius of convergence of this? This is nothing but limit supremum an raised to power 1 by n. So it is nothing but of this. So it is nothing but my 1 is there. So what is the right answer of this? R is equality 1, but he said greater than, less than, so only B is my correct answer. The power series convergent for this. So again, since the equality appears, we will check firstly at x is equal to plus 1. Fine. If x is equal to plus 1, this series becomes my 2 plus minus 1 raised to power n over 3 raised to power n. So how you can say it's a convergent or divergent? So how you can say? You have to apply the root test. So what is that? This is nothing but 2 plus of this. So what is that? It is 2 over 3 plus minus 1 over 3. So what is the limit of this part? So what is the limit of this? Is it a convergent or divergent? Because it's a convergent only for this. All okay. We will think about this by the radius of convergent. Fine. Okay, fine, that's easy. So I can take as limit supremum of an of this part. Fine. Now I have to use this. Take n is even and n is odd. I have to find the radius of one. If n is even, this value will be my positive. So 2 plus 3 is a 1. If n is my odd, this number is negative. It is my 1 over 3. So what is that? This is an of this. So can you substitute this value here? What is the supremum? Supremum is 1. So radius of convergence is my 1. Fine. Now it converges only of 0. 0 is my center. As I gave you the smallest tips in the earlier, when it will be convergent only at the center when r is my 0, but r is my 1. So this is cancelled. When it will be convergent for all when r is infinity, but again r is my 1. This option is also cancelled out. Now how you can say that whether it's a 1 equality 1 or not? How you can find the limit of this portion? That's the only thing. Now how you can say what is the limit of this? Limit n approaches infinity, an of 1 by n. So what is the limit of this? Is my 2 over 3 is a constant plus limit of this as n approaches infinity. So how you can think about this? Because if we apply the root test, fine. So I need this number should be less than of 1. So can you say this part will be 0? How you can say that? How you can? Okay, fine. Because this is a series and this part will goes to the infinite because it's a GP series. Fine. But any other way? How we can convince that it's a convergent or divergent? What is the limit of minus 1 raised to power n? Okay, you can also see that, sorry, it's not infinity. This limit does not exist because when n is even, then its answer is plus 1. If n is odd, this is minus 1. So it means limit does not exist. So it means this is not convergent. So if this is not convergent, it means at x equal to 1, the series is not convergent. So this option is also cancelled. Only option is my C is the right answer. Little bit calculation is there, thinking about that because the limit does not exist about this term. Okay, k is my positive integer and you can take any of the k. K is a positive integer. If I take k is 1, look at the answers are, it is a 1. It's a 1. Now you will get the same answer. So I can't take as a 1. If I take k is equal to 2, this is my 2. It is my 2 raised to power minus of 2. It is 2 raised to power 2 and it's now all are the different answers. So what I can do is I can simply take k is 2 so that your calculation becomes less. So what is that? It's the n factorial square divided by 2n factorial. So what is the radius of convergent? It is 1 over limit an plus 1 over an. So now if I found the an plus 1 over an, it is n plus 1 whole square and 2n plus 2 factorial divided by an. I can written this as a whole square into 2n factorial. Fine. Now I can written this as a whole square. N plus 1 will be pending, and this I can written as a 2n plus 2, 2n plus 1, and 2n will be cancelled out. So I can written this as n plus 1, and 2n plus 2 and 2n plus 1. So if I divided numerator and denominator by n square, the limit will be my 1 by 4. So if I substitute here, it is my 4 is the right answer. So I taking k is equal to 2. Which one is the 4 is? This is my 4. It is my 1 by 4. Remember, this is my simple term. 1 plus 1 over n. It's a 2 plus 2 over n and 2 plus 1 over n. So it goes to the 1 over 4. But the radius of convergence is 1 over this. So that's why right answer is 2 is 4. That's a C is my right answer. Okay, consider the polynomial here where a5 is my non-zero, b9 is my non-zero. Because it's a power series, that's why I'm counting here. Then the counting root with the multiplicity can be here. Fine, very simple. So if you multiply them, what will be the highest power of the z? It will be 5, it will be 9. So it is my 14th degree polynomial. Fine. Now since 14 is my even number, find at least 2 real roots. 14 can it be the 14 complex root? Yes, because complex root, we all know complex root occurs in pair. So if it is a 14 degree, so what is the maximum complex root they have? The maximum root they have 14 complex root. It is the right answer, but it's a part C. At least 2 real roots, 12 complex roots, 12 complex root, 14, okay, 2 real roots. Okay, look at that. This series as 5, 0 is degree 5. Fine. What is the meaning of that? It's an odd degree, and every odd degree has at least, yes, anyone? Yes, at least 1 real root. Fine. This is also the odd degree, so it also has the at least 1 roots. So what is the P of Z? It has at least 2 real roots, because 1 is corresponding to this, 1 is corresponding to this. So at least 2 real root is the, so no real root, cancel out. 12 complex roots, cancel out. Why? Because if you say that 12 complex roots, what about the other roots be? We can't say anything about that. So it has exactly 12 complex roots, but it may have the 12, 14 complex roots. So the right answer of this problem is A and B are the right answers. It's a 12 complex root plus 2 real roots, then it's a right answer. But you may have the polynomial like of this, where all have the 14 complex roots, but here this 12 complex root is a cancel out. Or you can construct any of the polynomial which has more than 12 complex roots. So that definitely this option is discarded. Look at this, another one. An is the sequence of the positive real numbers. K is my limit supremum an of 1 by n. Okay, this, can you relate this with the radius of convergence? It is nothing but my 1 by k. Fine. Now look at the options. K is infinity, convergent for every, okay, fine. What I told you in the earlier, if r is equal to 0, then the power series is convergent only at center. If r is equal to infinity, then the series is convergent for all these domain. Now look at that. First option, k is my infinity. What is the meaning of that? R is my 0. Then it convergent only at the center. Then it is convergent for every. That's wrong, because it is convergent only. So the first option is cancelled out. Second one, if k is infinity, it means r is my 0. R is 0 is not convergent for any. That's true. It is not. It is only at the center. but R is not the center, it's a not, that's why it's a correct option. K is equal to 0. K0, it implies R is my infinity. R is infinity, it convergent for all X, is convergent for every. Fine. X, remember in this case X is my R. Fine. K is equal to 0, again R is infinity, is not convergent for any, but it is strong, it is convergent for all. So this option is also cancelled. A and C are my correct options of this examples. So this is the way you can solve the power series in a very simple manner. We will see the next lecture on the PY question of the complex inner product and the Gram-Smith process. Till then, you can simply like, share and comment my video. Best of luck students. Happy